At its core is the reusable Space Shuttle orbiter, the winged spacecraft that housed the crew and cargo.
Providing the vast majority of propellant for launch, the massive rust-orange external tank fueled the orbiter's main engines. Together, these three primary elements formed a complete and integrated system, designed for repeated journeys to Earth orbit and back. Its black underside is covered in thousands of intricate ceramic tiles, a critical thermal protection system.
At its tail are the three Space Shuttle main engines, or SSMEs, liquid-fueled power. The massive payload bay doors, designed to open in orbit. Forward, the crew compartment housed the astronauts in a multi-deck environment. The flight deck served as the control center. This mid-deck provided versatile living space, accommodating crew sleep stations, hygiene facilities, and vital... Moving aft, the orbiter's massive cargo bay was... But perhaps the most critical component for safe return was the thermal protection system, the heat shield.
These high-temperature reusable surface insulation, or HRSI, tiles for the most extreme temperatures, such as on the wing leading edges and nose cap.
Once in orbit, the orbiter's orbital maneuvering system, or OMS engines, located in these Complementing the OMS engines are the numerous reaction control system, or RCS thrusters.
From the extreme heat of re-entry, every shuttle orbiter's design
As the X-ray view activates, the internal structure of the tank becomes clear. The external tank is the backbone of the stack. This protective foam is crucial, but equally vital are the structural attachment points. The orbiter attaches here, transferring immense structural loads directly to the tank's backbone. And to its sides, the solid rocket boosters, each with their own powerful connection points, providing the initial thrust. These connections are not merely attachment points. They're the sinews of the entire Space Shuttle system.
Central to this colossal endeavor are the solid boosters. Immense.
Unlike the external tank, the solid rocket boosters are designed for a spectacular return. Within their upper sections are housed sophisticated recovery systems, including multiple parachutes designed to deploy. This reusability is a cornerstone of their design, allowing for critical cost savings and sustainable space operations. Crucially, the nozzles can pivot or gimbal, allowing the boosters to steer the entire stack during the initial phases of
They are a testament to ingenuity, designed not just for power, but for a remarkable journey of reuse.
The pre-launch sequence begins long before liftoff. with the intricate assembly of the Space Shuttle stack. Once assembled, the entire stack, standing over 180 feet tall, embarks on it.
Crucially, the external tank is filled with over 500,000 gallons of supercooled liquid oxygen.
With fueling complete, final system checks are initiated. The umbilical connections. The iconic vapor plumes, formed by supercooled propellants venting from the external tank, serve as a visible sign that the These vital umbilical connections are the lifeblood of the shuttle during its final hours on the pad.
With all systems nominal and the final preparations complete, the Space Shuttle stack stands ready.
With a thunderous roar, all engines ignite, unleashing a colossal force.
The Earth falls away as the shuttle accelerates, punching through the lower atmosphere. The full stack, propelled by the solid rocket boosters, climb. High above the Earth, after 2 minutes of ascent, the solid rocket boosters near depletion of their immense power. With a precisely timed, powerful detonation, these critical bolts sever, releasing the expended boosters. With a clean separation, the solid rocket boosters gracefully tumble away, their mission accomplished.
Now unburdened, the orbiter and external tank continue their journey, propelled solely by the 3 main engines, accelerating towards orbit.
Jettisoned the external tank, the orbiter utilizes its orbital maneuvering system to finalize insertion into low Earth orbit. It is now entirely self-sufficient, relying on its internal systems and propellants to achieve its final orbital velocity and altitude. Engines provide the final thrust needed to circularize its orbit and transition from a suborbital trajectory into a stable low Earth orbit. Once these final maneuvers are complete, the orbiter is officially in low Earth orbit, ready for its mission to begin.
After the dramatic ascent, the Space Shuttle orbiter must precisely achieve its orbital insertion, a delicate dance in the void of space.
The Orbital Maneuvering System, or OMS engines, engage. These highly efficient engines provide the With the main burn complete, the orbiter is now on a stable trajectory, beginning its journey around our planet. The Space Shuttle orbiter has achieved its destination, now gracefully circling the Earth. Now, a symbol of human endeavor, it orbits our world, ready for its vital missions.
A truly remarkable machine, forever etched in the annals of space exploration.